This video will be about properties of numbers. There's lots of groups of numbers we can talk about, starting with natural numbers. Natural numbers are the counting numbers that we usually start teaching children, 1, 2, 3, 4, 5, etc., going on. Next comes whole numbers, which include all those natural numbers, but also include 0. We have one more number. So it's almost like the natural numbers can come down and fit inside the whole number category. Any number considered to be a natural number is also considered to be a whole number, but then whole numbers add that extra number of 0. Integers include all the numbers we've already said and negative numbers. Any negative number is considered to be an integer. But again, all the whole numbers can fit into the integers. So anything considered to be a whole number is also an integer. And rational numbers includes everything we've already listed. So it includes all the whole numbers, all the natural numbers, all the integers, but it adds a few more categories, all the numbers in between. So there's a couple ways to represent numbers in between. You can write them as fractions. Any fraction is a rational number. You can write them as decimals that stop. So like 0.25, that is rational. And decimals that repeat. Like 0.333333, just going forever. So these numbers, the fractions, decimals that stop, and decimals repeat, are only considered to be rational. But then all of these the negative, 0, and the positive whole numbers, those can fit in other categories as well. So if I were to say negative 10, that's considered to be rational, but also an integer. It fits in both categories. Or if I were to say 0, 0 is rational, integer, and a whole number. It fits in all three categories. The only category that's kind of by itself is irrational numbers. And these are decimals that do not repeat. There's one main way to make an irrational number, and that's to take the square root of a number that's not a perfect square. So like the square root of 12 would come out as the decimal 3.46410, and it just keeps going, but there's no main repetition going on. So decimals that do not repeat is irrational, but you do have to watch out. You'd want to always plug this into a calculator, because you could have a number like square root of 25 that just comes out as 5. So 5, that fits natural, whole, integers, and rational. It's in all of those categories, but it's not irrational. So here's an example of a question they could ask. Let x be a natural number. So right there, there's a keyword, natural number. We know that's any of our counting numbers. Which expression results in a number that can only be classified as rational? So it said only rational. So all of these, 1, 2, 3, 4, are rational, but it said only rational. So can't be an integer, can't be a whole number, can't be natural. So those were our fractions, decimals that stop, and decimals that repeat. So one of the easiest ways with something like this is to actually pick a natural number and plug it in. It's kind of hard to figure out when there's just a variable here what's going on. So it said x is a natural number. I'm just going to pick 1. Let's pick 1 as our natural number. So 1 plus 12 would be 13. 13 is rational, but it's also an integer, a whole number, and a natural number. It's not only rational. So let's check the next one. If we plug in 1 for x here, we get 1 over 5, which is a fraction. If we plug it into a calculator, we get the decimal 0.2. So this looks like it could be our answer. It's only rational. It's not an integer, not a whole number, not a natural number. But it's always good to check every single of your answer choices, just to make sure they're not trying to kind of trick you. So let's try C. If we plug in 1 minus 1/5. So 1/5 we already know is the decimal 0.2. 1 minus 0.2 is 0.8. So here's a second possible option for our answer. This is also only rational. Let's check the last one really quick before we decide between B and C. If we plug in 1 here, square root of 1 is 1. That's a whole number or an integer or natural, so it's definitely not D, and it was definitely not A. So we have to decide between B and C. So looking at B, is there any number we could plug in here so that it comes out as not only rational, but maybe an integer or whole number? So if we just run through, we could say, well, 2 over 5, that's still going to be a decimal. 3 over 5, still a decimal. 4 over 5, still a decimal. But then we hit 5 over 5. 5 divided by 5 is 1. That is a whole number, a natural, and an integer. So B can no longer be one of our answer choices. If we did that same process with C, and I'm going to keep using the decimal 0.2, so 2 minus 0.2 is 1.8. Or if we try 3, 3 minus 0.2 is 2.8. So we keep getting a decimal that stops, which is only rational. So our answer has to be C. Another type of question they can ask is just to take an expression and plug some of our numbers in. And they're going to give you all sorts of numbers. We have a couple rational, we have an integer, and we're going to plug them into this expression, a divided by bc squared. So we can't forget when you have two variables next to each other that really means they are multiplying. So this is really a divided by b times c squared. So we're going to plug in the numbers we have now. A, we're going to replace with 11 divided by 2. Over b, we're going to replace with 1 divided by 3 times c squared, negative 6 squared. Now when you do have a negative, it is a good idea to put that one in parentheses to make sure you know that, like this exponent is affecting the negative and the 6. So this can be hard to work with. We have a lot of fraction stuff going on. What I'm going to do is take these numbers that are fractions and turn them into decimals. So 11 divided by 2 is 5.5. 1 divided by 3 is 0.33333 repeating. So I'm going to use a whole bunch of 3's times our negative 6 squared. Now when you are working with fractions, you do need to have the numerator just as one number, which we do. 5.5 is one number only, and the denominator as one number. So we're going to focus on this denominator for now. So we have to take care of that negative 6 squared. When we do negative 6 squared, your exponent is saying multiply that number this many times. So negative 6 times negative 6. We're using this number, negative 6, twice. So negative 6 times negative 6 is 36. Now we can multiply the 0.33333 times 36. When we do that, we get 11.99999. Since we are using the decimals, sometimes we get kind of weird answers. But this is going to round up to be 12. There are so many 9s, we might as well just make it a 12. And then you can do 5.5 divided by 12, which is 0.4583, and the 3 just keeps repeating, 3. So we have this decimal answer. How are we going to compare that to these fractions? Well, if we take each of these answers and plug them into a calculator, we can compare to see which one has the matching decimal. So first we do 11 divided by 6, which is 1.83 repeating. So definitely not our answer. Then we try 5 divided by 6. That's 0.83, and again the 3 just keeps repeating. Not our answer. Then we do 11 divided by 24, and that gives 0.4583 with the 3 repeating. So that is our correct answer. So with our properties of numbers, we can also talk about rules involving positive and negative numbers. So for example, if you're adding two things and they are both positive, no matter what positive numbers you use, your answer will always come out positive. If you take something positive and add something else positive, always comes out positive. Same thing if you do a negative plus a negative. When you add those two things together, it will always come out negative. This is not true if you have a negative plus a positive. That could come out negative, it could come out positive, we don't know for sure. So there's no rule for those two. We also can do some rules for multiplication and division. A positive multiplied by a positive always comes out positive, every time. A negative multiplied by a negative always comes out positive. That's different than the addition. Addition always came out negative. Multiplication always comes out positive. And there is a rule for positive multiplied by negative. That always comes out negative. Now these multiplication rules also work for division. Positive divided by positive, still positive. We can also look at some rules for exponents. So if we have like x squared, let's say it's a positive number squared. Well, squared again just meant do a positive times a positive, which goes back to our positive times positive multiplication rule. So with the exponents, it's always good to write it out the old school way and say, well, that's a positive multiplied by a positive. This is what it would mean. One key thing to watch out for with exponents is negative x squared versus parenthesis negative x squared. If the negative is not in parentheses, the squared is only touching the x. So if we had negative 5 squared, the negative is separate from the 5 times 5, so you'd have negative 25. If we had that in parentheses though, negative 5 parentheses squared means do a negative 5 multiplied by a negative 5, which comes out positive. So you do have to watch out for those two different situations. So here's an example problem. Let x be positive. Which expression will result in a positive number? So anytime we have these kind of general rule, it's good to just pick a positive number. I'm going to pick positive 1. 1 divided by negative 3 is negative 0.333 repeating, so it came out negative. Negative square root x, negative square root 1, if we plug square root of 1 into a calculator, that's 1, and the negative was in front, so we get negative 1. Negative x squared, we plug in a negative or a 1 again for the x. The negative was already there, which is negative 1 times negative 1, or positive 1. Possible answer. Let's double check our last one just to make sure. Negative 1 squared. The negative is separate from the 1 times 1. 1 times 1 is 1, so we have negative 1. So our answer choice would have to be C. If you're ever in doubt, just try another positive number and see if you get the same results. We also have some properties for even and odd numbers. So an even number are all the numbers that are divisible by 2. 2 is even, 4, 6, 8, 10, 12, we could keep counting. So basically anything that ends in a 2, 4, 6, 8, or 0, except for 0 itself. So 10, 20, 30, those are all even. 0 itself is not considered even or odd. An odd number is when it's not divisible by 2. So 1, 3, 5, 7, 9, 11, and again we could keep going. If I did 1 divided by 2, I'd get the decimal 0.5. If you get a decimal, it's not considered to be divisible by 2. So there's our odd numbers. We also have numbers that are considered to be perfect squares. Those you can take the square root of and it comes out as an integer. We saw at the beginning, like square root of 25 is just 5, or square root of 16 is just 4. If you're not sure if it's a perfect square, try taking the square root. If we ask if 127 is a perfect square, when you square root that, it's going to come out as a decimal, 11.269, and again it keeps going forever without repeating. Not a perfect square, came out as a weird decimal. So always just take the square root of a number to check to see if it's a perfect square. So then one last type of thing for numbers is absolute value. An absolute value is just saying how far away are you from 0. So 2 is 2 spaces away from 0, and negative 2 is also 2 spaces away from 0. So when you take the absolute value of 2, it comes out as 2. But if you take the absolute value of negative 2, it still comes out as 2. They're both 2 spaces away from 0. So most people just think of absolute value as making a number positive. So here's our last example. Let x be an even number. Which expression results in an even number? So again, one of the best ways, instead of just trying to think about, well, what does that mean? What is this variable? Let's pick a number. So even number, I'm going to pick the smallest even number, 2. So everywhere I see x, I'm going to replace it with 2 and see what happens. So a, we have 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. That came out odd. X is 2 again. 2 plus 1 is 3. Also odd. Place x with 2, we have 2 plus 2, which is 4. This is even, so this is a possible answer. We always check all the answers just to be safe. 2 squared minus 1. 2 squared means 2 times 2. Minus 1, so 2 times 2 is 4 again. Minus 1 is 3. So our only even answer came out to be C. So a lot of information with this section, a lot of different math names. We learned natural, whole, integers, rational and irrational numbers. We learned about the rules of adding positive and negatives or multiplying positive and negatives. Learned about even and odd numbers. But one of the biggest things we can take away from this is if it's very generalized and you're not sure, well, what are they even talking about? There's a whole bunch of variables. Replace it with a number that fits the category they're talking about. If it says even, replace it with even. If it says odd, replace it with odd. Positive, replace it with positive. And that can help you kind of visualize a little bit better and look and see, okay, this is what's going to happen, and this is my result in the end. So that concludes our discussion on properties of numbers.